All right, so this is a problem that was requested online. This is on the Khan Academy practice test, and a lot of students are having problems with it. It says the base of a solid S is the region bounded by the ellipse 4x squared plus 9y squared equals 36. Cross sections perpendicular to the y-axis are isosceles right triangles with a hypotenuse lying in the base. Determine the exact volume of solid S. All right, so the first thing I notice here is that the cross sections are perpendicular to the y-axis. So what I have to do is I have to solve for x in terms of y. So in my first step, I'm going to subtract the 9y squared to both sides, and then I get 4x squared equals 36 minus 9y squared. Divide both sides by 4, and then take the square root. And when I take the square root, I get the square root of 36 minus 9y squared over 4. So what I'm going to do in this case here is I'm going to leave the square root up top, but I'm going to take the square root of the 4 on the bottom and leave it as 2. All right, so that would be my point for x in the first quadrant. But we need the distance across, so we need the cross section that goes all the way across. So that means we have to double that value to get that distance. Okay, so when I double that value, my distance equals the square root of 36 minus 9y squared. All right, so now the next step is to understand that we're using an isosceles right triangle and the hypotenuse is lying on the base. All right, well, an isosceles right triangle is a 45, 45, 90 triangle. All right, and how do we take the area of that? Well, it's going to be 1/2 base times height, and we're going to need the legs. So we're going to have to use that hypotenuse to work backwards to get the legs. Well, how do we get the legs of a 45, 45, 90 triangle? Well, if we have the hypotenuse, we divide by root 2. Okay, so this means if I calculate the area, it's going to be 1/2 the legs, and each leg is 36 is the square root of 36 minus 9y squared over 2. All right, well, if I square that, because it's the leg squared, that means I'm going to get 36 minus 9y squared inside my integral, and I can bring out a 1/4 out front. All right, so what's going to happen next? Well, we could see symmetry here. So the top half of the ellipse, we can do the integral from 0 to 2, and then just double it instead of doing the integral from -2 to 2. And that'll make it a little bit easier to do it by hand. So that means we're going to have to multiply this integral by 2, which would leave a 1/2 out front from 0 to 2. So if I take the definite integral of 36 minus 9y squared from 0 to 2, I should get the value of 48. And if I cut that in half, I get my volume is equal to 24.